All right. I think I made it to the right stream. Welcome everybody to a pre-calculus live stream. My name is Mr. McLogan. I do not expect a lot of people on. So if you go ahead and join in, then put your comment down below and I will be happy to have you on my live stream because this is actually the first time I think I have ever gone live on my pre-calculus channel. And it was actually something I decided to do late last night. So I didn't do any promotion for it or anything like that. ARF or RF. I don't know. I'm so like ingrained on the ARF. I'm so sorry about that. But RF, good to have you on. And so yeah, one of my goals was that I wanted to do, and I was thinking back to a time when I wanted to create some different channels. And then I was like, well, what do I want to do with those channels? And one of the things I really wanted to get back into was like having these channels and really them being teacher focused, where I am just focused on really doing the kind of instruction, kind of like I was going through the classroom, going back through my notes, going back through my tests and quizzes, and really helping students prepare for those courses. So that was my goal behind creating these additional channels. And then what happened is, things got in the way. I got busy, things changed, and I just kind of left these channels to be dormant, and I didn't really put any strategy on in them. But I also needed a break, I think, from doing a little bit of teaching, and so now I kind of have reinvigorated a little bit of that, and I feel like I really want to get into the teaching portion of it. All right, so I do see. Where's my screen? Where? There we go. All right, cool. Let me put it back on there. Aha. All right, cool. Now that feels much more better. So that's my goal in this. And I have my two channels that I'm posting constantly on is going to be pre-calculus as well as algebra 2. So what I'm thinking I'm going to do is for every Monday, at least until the end of this year, I'm probably going to be going live each and every Monday. And these are going to be much more math focused. They're not going to be like my regular stream, which I'm going to try to be consistent at 9 p.m. on Sunday night. That's a little bit more of like open live Q&A, just kind of have some chat and do some math as I have time. But for these, I really want to get into just the math focused. Yeah, there's nobody in here. And that's what actually feels better because, I did these a couple times ago and we'd have like 5 or 10 students would be going on. And it was awesome because we kind of got like that interaction. I actually used to do these on Zoom and students could kind of like share their screen. And I liked that. It was a good like intimate experience. Kind of like when you're in the classroom. But yeah, then Zoom has like kind of a feature where it can only get so big and I didn't want to do those at night. So it was kind of hard to keep them scheduled in the middle of the day. But the cool thing is the first time doing stream, I don't expect anybody to be here. And that's a cool thing. I'm going to work through the 3 math problems. Like there's 100 people in here and that's going to be cool. And Araf, if you have any questions or you want any other problems, then, feel free to go ahead and submit them or put them down in the chat. And we're going to go ahead and go through these problems that I did select. And these are actually ones that were actually submitted on my original channel, but they kind of were like pre-calculus related. So I wanted to go over them on this. So let's go into the math. Voila. And so, yeah, if you do have a question or submit, I will go back and open up my form. Let me see. Oh, that doesn't have it. Do I still have this open? Yeah, I do have it open. I do not have my open live Q&A. I do have the monthly PC pre-calculus Google form on there, which I have pinned in the chat. So, all right, that's not it. Let's get into these questions. So I'm probably going to try it. We'll see how long this goes. I'm not going to try to do an hour. If I can do 30 minutes, then that'd be great. All right, Scarlett, I am having a hard time with C. I like to simply be walked through this problem. All right, so we have radium-221 has a half-life of 30 seconds. Suppose we have 300 gram sample. A, find the formula for the mass remaining after T seconds. B, how much of the sample remains after 200 seconds? And C, after how much will it take? So C, after how much long will it only take After how long will only 20 grams remain? Okay, so let me get my thing here. All right, so let's kind of go through. Unfortunately, to really get to see, I got to kind of go through everything. So unfortunately, you're just going to get the whole gambit on here. Why is this not working? You got to be kidding me. This is not going to work. Come on. That has to be mine. Why is this not working? You got to be kidding. Wait, is that the wrong one? No. My pen, my style. I was just using this. Okay, I can't do this math if these are not going to be working. There we go. All right, you got mad. Yeah, RF, I see your question, and I will get to that. So after I'm done answering this question, so you don't have to like wait to the end, I will go ahead and address your question on that. Okay, I promise you. All right, let's go back and do this again because my computer, I think, was just being a little slow. So it says, Scarlett, I'm having a hard time with C. I'd like for you to simply be walked through this problem. All right, so we got this word problem, but unfortunately, if I'm going to go through or at least get to C, I got to be able to kind of go through all of the steps here. So let's first go and talk about the formula for a decay. Now, we're specifically have the half-life, but we'll talk about how that comes into. So if we're talking about a mass and we're talking about decaying mass, in this in particular case, we have a half-life. We are going to use this formula, which is going to be, come on, m of t equals m of 0 e to the k t. All right, so that's going to be when m of t is going to equal the mass at time t, where you're going to have m of 0 is going to be the initial mass, and t is obviously going to be the time, and k is going to be what we call our decay constant. All right, so the decay constant is always going to matter on like how fast and it is decaying in that regard. So when we have a half-life, we're going to have a certain constant. So that's what I want to, man, it is not liking this live stream. So that's going to be a decay. K is going to be equal my decay constant. Okay, so how do we be able to identify K? Well, in this case, we have the half-life, right? So that's really important because if we have a half-life, that means let's just for whatever time t, well, in this case, it has a half-life of 30 seconds. So let's go ahead and identify this portion here real quick. So if I have a half-life, that means it doesn't matter whatever the mass is, what the initial mass is. Let's say the initial mass is going to be 2. Then after the half-life, the final mass would be 1, right? So I could use like 1 and 2. Because obviously I don't want to use like 36 and 72, right? Let's keep the numbers easy. Then we have E, we have our constant that we do not know, and then we have T, which represents the time for the half-life, which in this case is going to be 30 seconds. All right, so now let's go ahead and solve for K. So to go ahead and do that, I'm going to divide by 2. I get 1/2 equals E to the K, or 30K. Let's write the 30 in front. Now, to go ahead and solve for the K, I got to get rid of the E raised to that power. So I'm going to take the natural logarithm on both sides. That's going to get rid of that E over there on the right-hand side. And now I'm going to be left with a ln of 1/2 equals, a 30K. And then in this case, I could write it like, I could just keep that in there. But just remember that you could also do this as ln of 2 raised to the negative first power, and then use your rules of logarithms to bring that negative down in front, right? So therefore, I can go ahead and solve for K, which is a negative ln of 2 divided by 30 equals K. So that is going to be our constant because we have a lot of variables going on here, right? We have our mass at time t, we have our initial mass, we have time, and then we have our decay constant. So we have identified what our decay constant is through the half-life at 30 seconds. And now let's get into the word problem. So it says, suppose you have a 300-gram sample. All right, so that is going to be our initial mass. Find the formula for the mass remaining after t seconds. Okay, so we don't know what it's going to be after t seconds. So that's going to be, let's do this. So let's do A. So I have M of t, which we do not know. All right, so it just says find the formula, right? So we're not actually going to figure out. So we don't know what M of t is. We know the initial amount is going to be 300, and that's going to be E raised. Now I'm going to use this formula for my K, right? So it's going to be a negative ln of 2 divided by 30, and then times T, which in this case is, we are going to have find the formula for the mass remaining after t seconds. There we go. So yeah, that's going to be your input, and that'd be then. So that would be your formula for in that case. Now, if we want to be able to figure out for B, how much of the sample remains after 200 seconds, well, now we have our time, right? So for B, that's going to be M of 200, and that's going to be 300 E raised to the negative ln of 2 divided by 30 times a 200. All right, now I did find my calculator that my students, or not my students, my daughters stole from me. So I'm going to go ahead and type this in and see what we get. So I'm going to do that negative ln of 2 divided by 30 times that by 200. And then I'll do E raised to that answer, and then multiply that by 300. And therefore, after 200 seconds, I am getting a 2.952. All right, and I'm just going to leave that truncated in that regard. So that's going to be how much of their mass is remaining after 200 seconds. Now, Scarlett, to your final part here, which is going to be for C. After how long will only 20 grams remain? So, yeah, I know. 20 grams remain. So that is going to be our final. So now we're going to be looking for the initial. So if we say, all right, so for 20 grams, we're looking, that's going to be our final amount. Now we don't know what our initial is. So that's going to be M of 0. That's what we're going to go ahead and try to find, right? After how long will only 20 grams remain? No, sorry, we need to solve for T. We already know what the initial amount is, 300. Sorry about that. So that one's going to be 300. And then we have E raised to this crazy thing, negative ln of 2 divided by 30 times T. Okay, so now we need to go ahead and solve for T. So to go ahead and do that, I need to isolate the exponential. Before I can take the log, I got to go ahead and get rid of this 300. So I'm going to divide by 300 on both sides. I can divide out those zeros. And then I have 2 over 30, which is going to be a 1 over 15. Excuse me. So I have a ln of 1 over a 15, which notice, just like I did over here, notice I can rewrite that as 15 to the negative first power and then rewrite the negative in front. So ln of 1 over 15, which really can be negative ln of 15. And that's going to be equal to this E negative ln of 2 over 30 times T. All right. So again, to get rid of this, or to get the powers off of our, to get the powers off of being a power of ln or of E. Wait a minute. What did I do? Oh, I'm jumping ahead of myself. That's just 1 over 15, right? That reduces to 1 over 15. Now we'll go ahead and take the ln of both sides. Sorry, I was like thinking ahead of myself. So now, rather than rewriting this as ln of 1 over 15, I'm going to rewrite this as a negative ln of 15. Okay, so hopefully I'm not jumping ahead for you. You can see we did that exact same thing over here, right? I'm just rewriting the 15 raised to the negative first power and then bringing that down in front. And then over here, I'm going to be left with a negative ln of 2 over 30t. Well, how do we solve for t? We got to undo what's happening to t. Well, what is happening to t? it's being multiplied by negative ln of 2 divided by 30. So I'm going to divide by negative ln of 2 divided by 30. And this is not really fun writing with this stylus, negative ln of 2 divided by 30. So now I can see that my negatives are going to go to add 0. And then also, I don't really want to rewrite this as a ln of 15 divided by ln of 2 divided by 30, right? If I wanted to get this 30 off the denominator, if I multiplied by 30 on the top and the bottom, those would divide out. And now I would get a final expression of t is equal to a 30 ln of 15 divided by a ln of 2. That's a lot easier for me to be able to go ahead and compute, right? So I'm going to rewrite it in that way. And again, as long as you multiply a fraction on the top and the bottom by the same number, you're producing an equivalent fraction. So I'm going to do 30 times ln of 15 divided by the ln of 2. Ln of 2. And in this case, I'm going to get 117.26. So time equals 117.206. So in that case, voila. So there you go, Scarlett. All right. Well, anyways, it's not awkward to me, to be honest with you. I just love teaching and going through this. So I'm just teaching through it. There'll be some replays, and eventually people will start getting the knack on this. So I'm not worried about it at all. Like I said, I only made one little post on my main channel, so it's all good with me. Actually, I didn't even send out an email. It's probably something I should probably be doing, but yeah, I just wanted to do some problems and go through on the Monday, and this will be something that will kind of continue for on the channel. So anyways, to go in on your question, I think the important thing that we need to understand about the zero product property is, yes, you would say that like tan inverse would be extraneous on that angle. But remember, like when I do like x, squared plus x is equal to 0, and you factor out the x, that's going to be x plus 1. My point that I was trying to get to you is x is equal to 0 or x is equal to negative 1. So even though you might have some extraneous solutions in that case, you only need it to be true for one of those things. So even if it might not be true on the one, it would have to be true going therefore on the other one. So as long as it's true for one or the other, so let's say pretend like this is a rational function or something like that, where this is going to be an extraneous solution. Well, as long as it's still true on these other one, it's still going to be a solution for that equation. So that's why it still works. So even if it doesn't work out in that case, it still matters in the solution, because that or simply says it's either one or the other, or it could be both. But it doesn't have to be true for all of those. It doesn't have to be true for both of those solutions. So that's the way that I look at it and explain it. But if you have anything else you want to add or further amount question on that, then let me know. Actually, I didn't look at the Desmos graph for that. That'd probably be the next thing I'd probably say to go and look at, is take that function and put it on Desmos and go ahead and take a look at it from on there. And then you might be able to see how those solutions work. Yeah, but I thought it has to work when you plug it back in your original equation. It does not. Let me look back at that problem. I'll look back at that one. Let me go and see. Actually, did I have, what was it? Was it tan? What was the problem again? Write it down and I'll go and take a look at it. Because how would it not one or the other? What was it? Tan of x plus sine squared of x, tan of x? Was that it? Equals 0? And then I think we said x was equal to pi halves plus what, pi halves n? Yeah, tan sine squared minus tan of x. All right, well, was that the solution that I gave? Tan sine squared of x minus a tan of x. And you're saying, yeah, since pi halves, that is going to be 1 over 0. That's going to be undefined in that regard. So that one makes sense. Yeah. Yeah, I might have. That makes all the sense. Let me think of. And maybe it would be all just extraneous solutions. Was it J Michael? Yeah, because those solutions. I see what you're saying though now. And that didn't come up when I was doing that live stream. But now I got to think. Oh. I don't have a great answer for you on that. It is giving you this. It is giving me the solutions though. When I type that back in as those points, if you're looking for the solutions when it's set equal to 0, but I guess when they would be equal to extraneous. Let me go and look into a little bit more research. It's like I said, it's been a while since I need to look at that. So I need to go back and looking from there. So I will I'll do some research. I got to remember, to be honest with you, it's been a couple of years now that I've been outside the classroom, so I wasn't doing these rhythm, but I don't recall doing something like that. So let me go and take a look. All right, let's move on to the next one, which is a bearings problem. Perry, can you explain everything about bearings on AP Calculus? Well, unfortunately, I didn't take AP Calculus, so I can't be able to explain everything on it, but I'll try to do my best. This one says a fire is spotted from 2 lookout stations that are 10 miles apart. The bearing from the first lookout station to the fire is north 52 degrees east. The bearing from the second lookout station from the fire is north 37 degrees west. Find the distance from each lookout station. Okay, so the one thing I always told my students when we're doing bearing problems is create your cardinal directions. So create a northeast, southwest. At every single time there is a point or a fire. Let's just undo these because that's horribly bad. So let's do one like that. We're going to do it like that. We're going to do it like that. And then we're going to do one right here. Okay, so I just do that for every single one. And that helps because now, if we look over from here to here, we can send that those are going to be 10 miles apart. And then we have this as a direction, and that is going to be north. So you always start at north, 32 degrees east. So that's going to be 32 degrees. And then from here to there is going to be north 37 degrees. west. Okay, so we have a triangle. We obviously need to find missing parts because it says find the distance from each lookout station to the fire. So let's call this little a, so that would be big A. Let's call this little b, so that would be big B. And then this could be big C. All right. Now, if this is 32 degrees, we know that this now has to be 58 degrees. Sorry, that's 52 degrees. How did I do that wrong? That is 52 degrees, so that's going to be a 38 degrees. All right, so we have 52. So therefore, that's going to be a 38 degrees, right? And then if that's 37 degrees, we know that this has to be a 53 degrees, right? Because these two angles have to make up a 90-degree angle. That's what's nice about having your cardinal directions. So now you can see that I have a angle, side, angle, which again, I can also find this third side, which is going to be, let's see, 180 minus 38 minus 53. So that's going to be 80. What is going to be 92, which is going to be what, 108? No, I don't want to make sure I'm making my math. Let's just do it. So that doesn't, no, that's 101. I'm just going to stop talking. 38 minus 53, 89. Wow. 80, 89, 90. Yes, that'd be 91. That adds up to 91. Yeah. Okay. So that's going to be an 89. Cool. All right. So again, we got that from 180 minus 38 minus 53. And that's how we got to be big angle C, which ends up being 89 degrees. Showing my work, which I got there. Okay, so now the nice thing is I have two missing side lengths, but I have the opposing angles. And I also have a ratio or a comparison between an angle and a side length. So therefore, I know I can use the law of sines. And I don't have to be worried about the ambiguous case because I already have my angles already defined here, and they all are acute, which is going to be nice. So we already have everything defined, so we're good there. So therefore, to use the law of sines, all I'm simply going to do is I'm always going to keep with this ratio here, and then I'm just going to create the ratio to find B as well as to find A. So to do that, I will say I always put the side length on top because you always want to solve for the variable on top. So it'd be A over a sine of 38 degrees is equal to a 10 over a sine of 89 degrees. That's going to be for A. And then for B, it's going to be B over the sine of 53 degrees is going to be equal to, again, 10 over the sine of 89 degrees. And now to go ahead and solve for A is going to equal a 10. I'll write that up in front, times the sine of 38 degrees all over the sine of 89 degrees. And then over here, I'll have B equals a 10 sine of 53 degrees all over the sine of 89 degrees. And now we just need to plug and chug. So do 10 times sine of 38 divided by the sine of 89. And in this case, I'm going to get A is equal, I'm just going to truncate it, 6.15. And then over here, I'll do a 10 times the sine of 53 divided by the sine of 89. And in this case, I get B equals a 7.98. Again, I'm just going to truncate everything. And do those make sense, right? If you have a 10 here, does it make sense that A would be 6.15 and 7.98 for B? Yeah, it does. Like it works, right? So that it makes sense, in that regard. Sometimes students will get like 61 or 798. And it's like, whoa. That doesn't really make sense in there on the triangle. So that's always good to kind of verify that and double check in that regard. All right, BZ Gamer 41, there is no height given. So I believe we have to use the law of sines or law of cosines here. So we need to find the area of the quadrilateral. All right, so if you were going to use the law of sines, law of cosines, like you'd have the angle side angle, but then I don't, I could find this opposing side length, but that's not really going to help me in my understanding to be able to find the quadrilateral. What I'm thinking we might want to do here is if I know this is 120 degrees, then I can figure out that to be 60 degrees. Now that's important because that's a special right triangle. And if I know a special right triangle, I can now I can make a 90-degree here. I can now find the height. So what I could do is if I can find this height here and also find this missing side length, then I have the height times the width and I have two triangles. Well, finding the area of a triangle is easy, right? Area equals 1/2 base times height. So if I have two right triangles, that'd be a lot easier to find the area of the rectangle and then subtract the two right triangles because I don't know what this figure looks like. This looks weird. So if we have 60 degrees, that's 24. Well, remember your special right triangles. If your hypotenuse is 24, your short leg is half of that, and your long leg is going to be 12 square root of 3. So then I have 12 plus 20 plus 12, that's going to be a 32. And then over here, if this is 6, and this whole thing is 12 square root of 3, then this is going to be a 12 square root of 3 minus 6. All right, so let's find the area of the rectangle. So the area of the rectangle is just going to be length, or let's just do base times height. Base times height, which in this case is going to be a 32 times a 12 square root of 3. And I don't want to rewrite that out, so I'll do 32 times 12, and I'm going to leave the square root of 3 out on side. So that is going to give me a 384 times the square root of 3. All right, now let's go and find the area of the two triangles and then subtract them. So let's call this area of triangle 1, and let's call this area of triangle 2. So area of triangle 1, that's going to be 1/2 base times height. So again, in this case, if you were to take this triangle, you could make, it'd probably be easy, it doesn't really matter which one's base or height, but I'll make this going to be the base, and then that would be the height. So if you were to rotate it on there, you could look at it like that. Or actually, it doesn't matter. Let's do 32 as the base, and that would be the height in vertical distance. It doesn't matter, actually. So we have a 1/2, and let's just do 32 times a 12 square root of 3 minus a 6. That's going to be a 16 times a 12 square root of 3 minus 6. And then I'm going to distribute that to both of them. 16 times 12, I should, but I'm not going to. 16 times 12 is going to be 192. So 192 times the square root of 3, and then 16 minus 6. Now, I'm sorry, 16 times 6, which would be 60, 90, 96, but I'm just going to multiply it anyways. Yeah, 96. Now, you might be asking me, why, Mr. McLogan, are you not using like decimals? Well, one, these are irrational numbers, so I don't want to multiply these until I finally get everything together. And then I'm probably going to be, since they all have a square root of 3, I can probably combine them close at the end, and I can get an answer that's going to be exact, and then we could do a rounded answer. So I'm going to leave everything with the radicals as they are. And then now let's go and do area of triangle 2. We'll have the base here of this one to be 12, and then the height here is going to be a 12 square root of 3. So I have a 12 square root of 3. All right, so I know 12 times 12 is 144. So therefore, to divide that by 2 would be a 77. No, that'd be a 70. 77, that'd be 154. So we do 6, that'd be a 72. So that's going to be a 72 times the square root of 3. Okay. Now, to find our area of our shape, that's going to be this thing. All we're simply going to do is take the area of the rectangle, which is going to be 384 times the square root of 3, and we are going to subtract that from the area of these two combined. So that's going to be a 192 square root of 3 minus a 96, and then you could add it to a 72 square root of 3. The reason why I'm writing that up is because we can go ahead and combine these first before subtracting them. So let's do 192, what, plus 72? 264. 34 square root of 3 minus, what's it, 264 square root of 3. And then also, that's going to be plus a 96. So plus a 96, because remember, you have to distribute that negative to end those. So I'm combining these before multiplying them together. Actually, you know what? That's confusing. Let's just rewrite it properly, so therefore you can see what I'm doing. So 384 square root of 3 minus, this becomes a 264 square root of 3 plus a 96. Wait, no, let's do minus. So I'll do a minus 96. And now you can see, and now I'll go ahead and distribute that. We'll do that correctly. Boom, boom, boom. And now we can do 384 minus a 264. That's going to be 120. 120 square root of 3, and that's going to be plus a 96. So that would be your final answer in that card. I mean, you could factor, I'm assuming, out like a common factor between those two, but I would just leave it in that case. And then if you want to approximate it, you could do 120 times the square root of 3, and then go ahead and add that to 96, and that's going to give us a area, and I will just truncate it here at 303.84 if you needed to approximate it. So, whew, voila. All right. Yes. Hey, first name. Glad to have you join on. All right, ladies and gentlemen. Well, that is the first stream. Let's see. Did I get any more questions that trickled? Oh, I did get another one. Finding the f of x value. All right. So let's see what else we got here. And again, I will plan on be going live. I'll let you guys know. I think next week I am going to do an Algebra 2 live stream on my Algebra 2 channel, and then I'll come back and do another pre-calculus one. I'm having issues. No, that's apply problems with law of sines, law of cosines. I just did the one. Got another one with law of sines, law of cosines. Let's see. Oh, cool. Well, Busy Gamer, I just did your problem. So awesome. Thank you so much for submitting it. And guys, thank you so much for joining in or on watching the stream. I will be back. So take a look. Make sure you guys have that notification down on it, because I would like to say I would be back here in 2 weeks, but sometimes my schedule gets messed up. So I will make sure I get it scheduled in advance for the next time, so you guys are all well aware. And then you can also make sure you check on my main channel. I'll make sure I have, I'll probably have something posted there for the first two, so therefore you guys are away. And then also I go live every Sunday on my main channel at 9 p.m. So feel free, if I did not answer your question, you can go ahead and submit it there. And thank you so much for being my soldier student as getting me through my first live stream on my pre-calculus channel. I'm hoping to grow it, and I'll look forward to seeing you guys on the next one. Cheers.